Welcome back to C++ with Miyoshi. We're going to talk a little bit more about structures today. And the thing with structures is sometimes you can have structures made of structures. And so we have, over here I have a structure, so let's set this up a little bit. I have a couple points and maybe we're doing a little bit of geometry or something like that. But I have 2 points in here and I have P1 and P2. I know they have X1, Y1, X2, Y2. And you can't do these little subscript things with in C++ or in programming, but I have them there just for illustration purposes, and I want to find the distance between the 2 points. Well, I can make a point with the structure. So I can create a structure called point, and I'll have my open close curly brace with my semicolon, of course, and I have 2 floats, an x and a y, and that defines each point. So I have a point here defined by an x and a y, just like I have a point in space defined by an x and a y. Well, I can also make a line, a structure called a line, and in this case I have my struct line, and I have, again, my open and close curly braces with my semicolon at the end, and I have my point P1 and P2. So my line is just created by 2 points. I don't have to do float x and float y again. I don't have to make 2 sets of x and y's. All I have to do is make 2 points, point P1 and point P2. So my line has now 2 points in it. And if I was to draw that line over here, maybe it's going to be L or L1 or whatever I want to call it. But that line is now defined between those 2 points. So over here, I create 2 functions. I actually have 1 function and name, and I have 2 different signatures, if you will. And so I have a float dist, open parentheses, point P1, point P2. So again, I use that structure over here, the point structure, to get my 2 different points. And all I'm going to do is I'm going to create, if you remember the distance formula is, the distance is x2 minus x1 squared plus y2 minus y1 squared, and all of that squared over all that. That's my distance. Well, I can't do all that stuff. I'm not going to do all that stuff in one fell swoop. I could, but all I'm going to do is I'm going to define dx as assign the value. Oops, that would be a float. I can put a float there, and a float there, and a float there, and a float there. So I have a float called dx, and that's assigned the value p2, which is my point 2, comes from my argument there. X minus p1, it's x. Notice that dot notation again, and then I have a float dy is p2y dot y minus p2 dot or p1 dot y. Then what I'm going to do is I'm going to square them, which is just dy times dy. That's dy squared, just like I have over here, and dx squared. That's dx times dx, which is just those guys squared. And I take the square root of that, which is in math.h. If I make sure I do a pound include math.h, it'll be there. Square root of that guy and return that back, and that gives me my distance. Just exactly like my formula shows. Okay? Now, here's something I didn't talk about when I talked about functions. I'll probably put that in there as another new video someday. But I have what's called an overloaded function. Notice it's the exact same as this guy, except for my arguments are different. So I have the exact same function, float dist, same name, same return type, and it's got a different arguments. And those different arguments in this case is just a line. So my line L1, it gets sent to my function, and it now is going to be how I find my distance. And so in this case, I again have my float dx is L1, which is that guy L1, dot P2 dot x. So notice I have my dot notation twice. So if I look here, get rid of that L1, it's exactly the same as it is up here. So L1 is just the same as P2 dot x. But I didn't get a P2, I got an L instead, an L1. So my L1 says the point 2 of L1, the x of the point 2 of my line, L1, I take that and I take the x value of the P2, P1 of my line. I take those 2 guys, subtract them, and that gives me dx. And again, I have my y of P2 of my line, and my y of my P1 of my line. So my y value of the point 1 of the line and the y value of the point 2 of the line, those guys are going to get subtracted, and then I'm going to take the square of each of those guys and take the square root of that sum, and that's going to give me my distance. So whether I have the overloaded function in this case is going to give me the distance between the 2 points, whether I send it as a line or as 2 different points. And again, I'm going to show that here down in my main. I declare 2 points, and I declare a line, and I do something in between there. I didn't put the dots there, but I have something in between there that gives me my values, sets my values there for me, and then I could do the float d is my distance between my 2 points, or my float dl is my distance of my line. Again, the nice thing about this is I use structures to hold my data, and I have, in this case, a structure that's got my point, and a structure that's got my line, which is indeed 2 points. Not for floats, but just 2 different points, and each of those points has 2 values, an x and a y. So, and again, it illustrates nicely my dot notation and the dot notation for structures inside of structures. So, more things about structures, and again, structures are new data types, or creating new data types from old data types, and it just shows you here that I can create structures with structures, or structures with other data types as I need to. So use these, again, in your programs that need them, and that it's necessary to hold lots of different data together. But it's another tool that you have for programming in C++. Thanks for tuning in, and we'll talk more about other things in C++ next time. Thanks again for tuning in.